Hey there, this is Miss Padberg, and I'm going to talk you through the main points of Chapter 2, Seeing the World Like a Geographer. And we're going to explore the essential question, why do geographers use a variety of maps to represent the world? We're going to use the information that you gathered out of Unit 1 in your map skills in terms of key, scale, compass rose, projections, in order to be able to interpret the wide variety of information that can be shown in a map. I'm going to do this in two parts. Our first part is going to focus on physical geography. And physical geography, remember, is all of the things that were created by nature, things that naturally occur here on Earth without any human intervention. So one kind of map that you're going to see is going to involve physical features. And I know that you're already familiar with physical features in terms of mountains, oceans, rivers. There are some terms that are easily recognizable, but I'm also going to introduce you to some other terms that you may not have had much experience with before. In terms of landforms, we're going to be discovering the Amazon basin, which is, I like to consider this a bowl shape. Between higher elevations, water is going to drain to the lowest point, and so you're going to have a bowl with usually water collected in the form of either a river or a lake. You're also going to see an isthmus. We're going to discover the Isthmus of Panama, which connects North America and South America. And the definition of an isthmus is a narrow strip of land that connects two larger pieces of land. Some other fun words. I love the word archipelago, just a lot of fun to say. And it is not just a single island, but a chain of islands that together create a common space. This is an archipelago. Think of Hawaii or Japan. Another term that you may have heard before and can be either a landform or a body of water is considered a delta. And a delta is the place where a river meets a larger body of water, and as the water slows down, it deposits all of the soil and rocks that it was carrying through its current, creating a marshy, swampy area, which is often very fertile and good for farming, but then also has some challenges in terms of the stability of the soil. We have a large delta at the Mississippi, the mouth of the Mississippi in Louisiana, and we'll be discussing the river delta of the Nile in Egypt next year in 7th grade. You're also going to come across some different bodies of water that you may or may not have heard of before. The opposite of an isthmus is what's called a strait. Notice the spelling. This strait is a narrow body of water that connects two larger bodies of water and can become very strategically important in military campaigns because if you can control access to this one tiny piece of water, then you controlled all of the water access into the other large body of water. You'll also find a gulf. A gulf is surrounded by land on three sides, but it is open to an ocean or sea on one side. We're going to discover the Hudson Bay, which is another version of a gulf, which is again open into one side. Oftentimes a bay is considered to be smaller than a gulf. But occasionally, when you find examples on the world, the size isn't an indicator of whether it's a bay or a gulf. You just have to look at the name and figure that out. So an example of a physical features map would be one like India. And the key things to look for in a physical features map are going to be the elevation colors. These are pretty standard, and so you'll usually find your highest elevations, your mountains, to be in an orange or red color, and your low, plain, flat, grassy areas to be in greens, shades of green, so that your eye can quickly tell, oh, this is a flat area, getting to be more mountainous, and then to the highest mountain peaks in the world in the Himalayas. You're also going to notice that on a physical features map, the features themselves are actually labeled. So you'll see that this is labeled the Arabian Sea. You'll see that this is labeled the Thar Desert. So you're not only going to find information in the key, but you'll also find information labeled in the map itself. In addition to physical features, you're also going to discover climate when you discuss physical geography. And climate is due to the long-term weather patterns over time. And so you're going to be saying it is hot in Australia in February, not today was 90 degrees outside. When you're talking about the weather, that is the current temperature or the current precipitation. When you're talking about climate, you're talking about general patterns over time, which is why you'll often see a climate graph like these we have here, shown in your textbook, which show levels of precipitation, and it shows an average for each of the months of the year. So we're not talking about a particular day or a particular month, we're talking about long-term patterns over time. Some of the key terms that you're going to hear when you talk about climate are going to have to do with levels of precipitation. And precipitation can be any kind of moisture, rain, snow, sleet, any of those kinds of moisture. Or, in the case of Australia and the desert, lack of moisture. So arid is a term that refers to dry. And arid doesn't always have to mean hot and dry, although usually those terms go together. But arid means dry or lack of moisture. You're also going to see a reference in climate zones to the idea of something that is tropical. And tropical has to do with those terms we talked about in latitude and longitude. 23.5 degrees north and south are the tropics. And that's going to be your hottest, wettest part of the globe. And then you're going to get into the Arctics, which are going to be your coldest, driest parts of the globe. You're also going to hear terms like humid, and I think here in the continental United States we have good experience with humidity, and the fact that the air feels very heavy. It's usually a thick air that has a lot of moisture in it. And you may also then hear the term tundra. And there's not a tundra in Australia. However, there is a tundra in Alaska. And a tundra is going to be very cold, but it's also very dry. So not necessarily a lot of snow or rain, but still very cold temperatures. So there's two things that are going to impact your climate. Your location on the globe, as I mentioned, if you're near the equator, you're going to be much hotter than if you're near the poles, North and South Pole, where it's going to be much colder. But also your elevation. So if you remember our map of the Himalayan mountains, our Himalayan mountains are actually going to be very cold at the summit of those mountains because the air is much thinner, and yet the Mount Everest, the tallest point in the world, is in very close to the tropics. Yet it's never going to experience a tropical climate. So location on the globe due to your latitude will impact your climate, but so will your elevation or altitude into the atmosphere. Climate is also going to impact the types of plants that are going to grow, which is the final form of physical geography that we're going to talk about. And geographers aren't necessarily going to use the term plants. They're going to talk about vegetation. So think about your vegetables, and that's the vegetation that you're going to be discovering in a vegetation map. And you're going to have vegetation zones, anywhere from frozen zones where there are no plants to scrub grasses, different kinds of trees, different types of grass areas to dry desert areas, and then finally to large plants and tropical forests. So some of the key terms that I need you to understand when we're talking about vegetation is the idea of 3 different types of forest. You're going to hear forest, which I think we have a picture in our head of what forest is like here in the United States. However, forests have different characteristics depending again on their location. A coniferous forest is what we might consider to be a pine cone forest. These are the kinds of trees that don't lose their leaves, their needles. They need to be strong and thick to survive in areas with lots of snow and cold winters. Then you're going to find forests like we have in our area, which are called deciduous forests. And deciduous forests are trees like maple, oak. They lose their leaves in the winter, grow new, beautiful leaves in the summer, and often have flowering plants as well. The final kind of forest that you're going to discover is the broadleaf evergreen forest, or in simpler terms, the rainforest. These types of trees are going to have large leaves, which is why they're called broadleaf evergreens. And evergreen also means that they stay green all year long. They don't lose their leaves. However, they are not the same type of leaves as pine cones, which also stay green all year, however, have very different needles instead of broad leaves. So those are the three types of forest that you need to think about, and they are found in very different parts of the world. When you see a vegetation map, you're going to notice that it's going to have very similar colors to a climate zone map because, again, your climate is going to impact your vegetation. In this case, the red is going to indicate more moisture or more green leafy plants. So you'll notice that in this map of Northern Africa, of Egypt specifically, the very obvious impact that the Nile has on creating that broadleaf evergreen forest in the midst of desert and desert scrub.